So let's go to page 31, and we'll take it from there. So if I ask you to graph, you choose which order you want to go in. It's going to involve finding intercepts. Not always. Special cases are easier to do, and it's going to involve finding rewriting it in some form. Okay. So this particular, you've got two inequalities. This one should right away grab your attention. You're like, oh, this is a special case. Okay, it is a vertical line. So basically, if you see this, you know that this is going to be dashed. The true region in this case is going to be to the left of the boundary line. We're going to shade to the right. Why are we shading to the right? Because we're using reverse shading, because it's a system. It makes it easier to find the solution region. That's the only reason why we're doing that. So this is the most important thing when graphing, to know where to shade. And it should always be opposite to where the true region is. Okay? So if you're going through your notes, at the beginning I shade the true region, so you're like, okay, true is the same as shading, right? Like it's the same region, but then all of a sudden we make this switch. So this is what I'm going to tell you. If you just want to stick with reverse always, it's fine. Just label the true region and you're fine. Okay, label the true region. This one here, we know this is going to be a diagonal one, a diagonal line. I'm just going to draw your attention to this. Both of them have the same coefficient, 1 and 1. So you'll see something interesting. It's actually very easy to do when it comes to intercepts. So if you go and find the intercepts, you get the same value. So right, if y is equal to 0, x is equal to 2. If x is equal to 0, y is equal to 2, right? So you've got the 2, 0 and the 0, 2 happening here. So not much to it. I'm going to rewrite y is greater than or equal to, the x comes over to the other side like that. Okay, x turns negative because it crosses the sign, the inequality symbol. And once you have it isolated, you can do talk about, right, what is the line going to look like? It's going to be solid because of the equal sign. The true region, when it's a y scenario, it's either above or below. And in this case, it's above, right? The true region is found above. I'm going to shade below. I'm going to do the opposite of where the true region is. So now you've done, like, right, with two inequalities, you're ready to graph now. You're ready to graph. So let's go ahead and make our scales and all of that. So I'm going to go put arrowheads all around x and y. I recommended you graphing this on your calculator before you do it on your piece of paper. Strongly recommend you do that. So I'm going to take a moment to do that. I already y3. I already have the 9 nines, and then I want to graph x is equal to 4, correct? So I have to go x minus 4. If it's positive 4 that you're graphing, you got to go minus 4. Maybe I should tell you that here. To graph on calculator, because I know you're going to forget. And you're going to forget. So we're going to go 9 nines, and then I'm going to go x minus 4. That's what I'm going to enter. And I'm using y2, y3. It doesn't really matter. Let's enter this one. Negative x plus 2. And there are my two lines. That's what I expect. I can see where they intersect. So having a small 10 by 10 by 10 will do just fine here. Okay, it's not somewhere far off to the side, right? So we know this is what we expect. So let's see here, 0, 2, 2, 0 is my diagonal line. Make sure you use a ruler. It's a solid line, right? So I can go right across the whole grid. Some students just want to stick with the 2 points and don't go too far off. Go right across the whole pane, okay? So this is going to be the y is greater than or equal to negative x plus 2. And then the 4 line goes through 4, 0. And that is a dashed line. This is the x is less than 4 inequality right there. And then I shade. I'm supposed to shade below the diagonal line. So just go ahead and put your ruler there. That's all false. Some of you are going to have some beautiful shading there. I just do it that way. That's good enough for me. And then shade to the right for the dashed line. So everything to the right of that one does not work. It's not going to work for the system. It doesn't work for this inequality, and therefore it also doesn't work for the system. Okay, so this is my true region right here. Solution, either one. I like solution more, especially if you have more than one, because you're saying, hey, this works for all of the inequalities involved. And do I ask you for the POIs? Yes, I do. Points of intersection. So that is where the boundary lines meet. And in this case, there's only one. I'm going to use a red pen for that. Right? This is the POI right here. And we're going to find it. Okay, I already have it in my calculator. I just have to go second trace 5 and just hit enter 3 times because there's only 2 lines involved. And it ends up being 4, negative 2, which is what you expected, x being 4. So 4, negative 2 is this point right here. You got it. Okay. So that's how you do a 2 inequality system. Then again, is negative 720 a solution to the system? We have to check. I'm going to plug it into both of these. So x is negative 7 plus 20 is supposed to be greater than or equal to 2. This ends up being 13 is greater than or equal to 2. That is true. Okay, that actually works. Then you also use this one and plug in the point. All you have is x in this inequality, so just put the negative 7 in here. Negative 7 is less than 4. That is also true. Therefore, it is a solution. A solution. You've got lots of solutions. In fact, you have infinity number of solutions because this just keeps going further and further apart. And so you actually have more and more answers as infinity goes on. Is that even a thing, as infinity goes on? We just made it up today, right? One more. I don't know if you tried 32. I put in it's actually a fairly common one that you may encounter in life, but it's a bit of a pain to graph. Okay, so I'm going to go to 32 and do that one. So you can't say I didn't give you enough examples. And starting Monday, I want to switch over to word problems. So I'm teaching you how to do inequalities, how to deal with it, and then we're going to go over to word problems. So most of the test, even on the exam, is going to be more word problem focused. Okay, so I'm not going to spend too much time on just inequalities in general. They're going to have a context around it. So you're going to have, number of items produced here and another variable there, right? It's x and y are actually going to have a meaning here. Let's go to 32. I want you to learn to deal with that x and y there, this one, this inequality right there. Let's do the left one first. It's the way I want it for my intercept, so I'm just going to go ahead and just do this. If I let y equal to 0, it's x is equal to 6. So 6, 0 is my x-intercept. If I let x be equal to 0, I end up with 2y is equal to 6. Divide both by 2. Y is equal to 3. So 0, 3. Is that right? Yeah, we're good. Keep in mind, folks, what am I doing here? I'm for a moment forgetting that this is an inequality. I treat it as I'm looking at the boundary line where you can basically replace this with an equal sign, and for a moment I just focus on the boundary line here to be able to graph it. And then I switch again over to inequalities when I rewrite it. So it's 2y is less than negative x plus 6. Divide everything by 2. Y is, don't forget about the fact that if you divide by a negative, that you flip the sign. Okay, especially when you do the AC, don't forget that. Once I have this, I know this is dashed. True region is below. I'm going to shade above, so I'm going to circle that one. That's very important to me when graphing. And now this one, okay? What I want you to make a note of is that this one has no constant. Like it doesn't have like a 3 or a 2 or like a number just on its own, so it's special. You're gonna every once in a while come across one of these. So maybe highlight it so you figure that out. How is that special? How does this make sense? Watch this. If you try to rewrite it, you end up with this. Like if you bring the y over to this side, you end up with this. Okay. To find your intercepts, I don't know if you've already tried. What are the intercepts here? 0, 0 for both, and that's the annoying part. Because if y is equal to 0, then x is equal to 0, so that's 0, 0. If x is equal to 0, you end up with negative y is equal to 0. Divide both sides by negative 1. It doesn't really matter. Y is equal to 0 also. 0, 0. So that is the problem, okay? That both of them are 0, 0. So you can't have two distinct points to connect. Got it? So you need to kind of do something here. Pointless. It is pointless to find intercepts. Line goes through origin, and you may have already looked at the key, so then this kind of is just repetitive. Line goes through origin. So what you can do here is how did I do this on the, yeah. By the way, if you have it like this, follow me here. I like to have the y on the left side. So I'm going to go negative y is less than, what happens to the x when it goes over to the other side? It goes negative like this. And I don't want negative y, so I'm going to have to divide by negative 1 and negative 1. And what happens to this? It flips, right? So you actually have it the other way. Like that. So what you do here is you just get a second point. Okay? Point number 1 is going to be 0, 0 for sure. But you need a second point. So what you can do is decide anything you want for x. Choose anything you want. Let x be something. And I'm looking at my other values. They're not too big. So I'm going to let x be 5 and then figure out this part right here. Okay? how should I show this? So I'm going to plug in the 5 into there, and basically if x is equal to 5, then y is also equal to 5. Okay? So the point, the second point that you've just determined is 5, 5 in this case. So this is point number 2. If you picked 10, y would have been 10. If you picked 11, y would have been 11. If you picked -2, y would have been -2. So that's what this is saying. It's going to be like that. So that's your second point right there. Okay. All right. Doesn't happen very often, but that's how I deal with it. Let's keep going. This is x, this is y. Oh, I should have, based on this is going to be dashed. The true region is above the line. I'm going to shade below. So now let's go ahead and graph it. So the first one is 6003, and it's dashed. You don't have to do it exactly like I do it, like how I approach it, but I'll tell you this, you will make fewer mistakes if you approach it my way, because I kind of, the way I do this is to avoid mistakes that I've seen in the past. So this is the first line here, and then this one is my second, and I'm going to use these points here, 0, 0, and then 5, 5. Okay. That's also dashed. Oh, I should have probably graphed it before on my calculator before, but we know that it's crossing right there. It's going to be visible. The point of intersection is visible. Now shading. This one I have to shade above. So I go here and just shade everything above it. This one I have to shade below, so I go to that line and shade everything below it. Here we go. So this is your solution region. I didn't label this line, so I'm going to do that right away. That's y is greater than x, that line, and I just need to find the point of intersection. I'm going to spare you the details and just say that that's 2, 2. If you type this into your calculator and you find that, this is the POI, which is 2, 2. You don't have to label it on the graph. You can just state it if I ask you for it on the side. And is -12, 7 a solution? -12 would be somewhere here and 7 over here. We know by observation that it is. Okay, I will just show you the answer key here because I want to get going with this. So here's this here. If you plug in, if you grab both original inequalities and you plug in -12, 7, right, you find out that both of them are true. So -12, 7 is a solution to the system. All right. Okay. We're going to stop here.